Welcome back to our channel, where we explore the mysteries of the universe. Today, we have an incredibly fascinating topic to discuss, the missing baryon problem. Get ready to dive into the depths of space and embark on a journey to unravel one of the most perplexing cosmic enigmas known to mankind. Before we begin, be sure to smash that subscribe button and hit the notification bell so you won't miss any future mind-expanding content we deliver. Let's get started. Have you ever wondered about the composition of the universe? Well, scientists have made incredible discoveries, but there's one thing that still baffles them: the missing baryon problem. But first, what are baryons? Baryons are the building blocks of matter, consisting of protons and neutrons, essential for the existence of stars, galaxies, and even us. Now, imagine this: you have a jigsaw puzzle and are missing a crucial piece. The missing baryon problem is somewhat similar. Astrophysicists believe that around 50% of the universe's normal matter, the baryonic matter, remains unaccounted for. So, where did it go? Let's delve into the various places where scientists have been searching for these elusive baryons. First up, our very own galaxy, the Milky Way. We know that matter exists within galaxies, but what about the vast regions between them, the intergalactic medium? In the intergalactic medium, baryons can exist in the form of hot, ionized gas known as plasma. Scientists have employed advanced observatories to detect this plasma through absorption lines in the spectra of distant quasars. Surprisingly, they found less than expected, adding more to the mystery. As we venture further beyond our Milky Way, clusters of galaxies have been another intriguing hunting ground. These clusters can contain enormous amounts of hot gas, which scientists believe should hold vast sums of baryons. However, observations using X-ray telescopes have revealed that a significant portion of the expected baryons are still missing. What about the vast cosmic web, a network of filaments that connect massive structures in the universe? Surely, these interconnecting strands should be teeming with baryons. Well, scientists have indeed discovered some missing baryons in this web, but not nearly enough to account for the missing percentage. So, where could the remaining baryons be hiding? Some researchers hypothesize that a vast majority may be concealed in the form of low-density warm halo gas surrounding galaxies. Others suggest that they may be lurking in yet undiscovered cosmic voids waiting to be detected. To add more complexity to the puzzle, let's introduce a couple more cosmic mysteries: dark matter and dark energy. Dark matter is a mysterious substance that remains invisible, undetectable through traditional means, but its presence can be inferred by its gravitational effects. Dark matter, unlike baryonic matter, is thought to reside mostly in halos surrounding galaxies, helping to bind them together. However, could dark matter play a role in causing some of the missing baryons to remain elusive? Scientists are actively investigating this possibility. Now, let's talk about dark energy, which is even more enigmatic. Dark energy, as its name suggests, is responsible for the accelerating expansion of the universe. But could it somehow be linked to the missing baryon problem? Some theories propose that dark energy might be causing the baryons to disperse and distribute unevenly throughout space, making them harder to detect. Astrophysicists are not giving up on the hunt for these missing baryons. They're resorting to ingenious techniques to find them. One intriguing method involves using highly sensitive instruments, like the upcoming James Webb Space Telescope, to observe the subtle imprints these baryonic matter clumps leave on the light from distant galaxies. Another exciting approach is to study the cosmic microwave background, which is the afterglow of the Big Bang. By measuring subtle temperature fluctuations, scientists hope to uncover more clues about the presence and distribution of these missing baryons. Ultimately, solving the missing baryon problem will give us a better understanding of the evolution and structure of the universe. It's like discovering the final pieces to complete the cosmic puzzle. We eagerly await the breakthroughs that will undoubtedly come in the future. And that's it for today. We hope you enjoyed this deep dive into the missing baryon problem. Don't forget to like this video and share it with fellow space enthusiasts. Also, leave your thoughts and comments below. What do you think happened to those missing baryons? Do you have any theories of your own? Remember to subscribe to our channel so you don't miss out on the awe-inspiring mysteries we explore together. Until next time, keep looking up to the stars as the universe continues to reveal its secrets.